Newton's first law of motion predicts the behavior of objects for which all existing forces are balanced. The first law, sometimes referred to as the law of inertia, states that if the forces acting upon an object are balanced, then the acceleration of that object will be 0 meter per second. Objects are equilibrium, will not accelerate. According to Newton, an object will only accelerate if there is a net or unbalanced force acting upon it. The presence of an unbalanced force will accelerate an object, changing its speed, its direction, or both its speed and direction. Newton's second law of motion predicts behavior of objects for which all existing forces are not balanced. The second law states that the acceleration of an object is dependent upon two variables: the net force acting upon the object and the mass of the object. The acceleration of an object depends directly upon the net force acting upon the object, and inversely upon the mass of object. As the force acting upon an object is increased, the acceleration of object is increased. As the mass of an object is increased, the acceleration of the object is decreased. Newton's second law of motion can be formally stated as follows. The acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. This variable statement can be expressed in equation form as follows. Acceleration equal F net per meter. Consistent with the above equation, a unit of force is equal to a unit of mass times a unit of acceleration. By substituting standard metric units for force, mass, and acceleration into the above equation, the following unit equivalency can be written. 1 Newton equal 1 kilogram multiplies meter per second square. The definition of the standard metric unit of force is stated by the above equation. 1 Newton is defined as the amount of force required to give a 1 kilogram mass and acceleration of 1 meter per second. Newton's second law as guide to seeking the numerical information in the table above demonstrates some important qualitative relationships between force, mass, and acceleration. Comparing the values in the rows 1 and 2, it can be seen that doubling of the net force results in doubling of the acceleration. Similarly, comparing the values in rows 2 and 4 demonstrates that a halving of the net force results in halving of the acceleration. Acceleration is directly proportional to net force.